The James Webb Space Telescope, JWST, humanity's most advanced tool for peering into the cosmos, has once again unveiled astonishing revelations. Its latest images and data are reshaping everything we thought we knew about Pluto. Once dismissed as a barren, ice-covered dwarf planet lingering at the edge of our solar system, Pluto is now being recognized as an active and complex world teeming with geological and possibly even biological intrigue. Pluto, previously relegated to the status of a remote outlier, is emerging as a vibrant planetary body. Detailed observations from JWST have revealed dynamic features including evidence of tectonic activity, thermal anomalies, chemical diversity, and vast subsurface oceans. These findings are not only rewriting planetary science textbooks but also reigniting the search for life in the most unexpected corners of the solar system. At the heart of these revelations is Sputnik Planitia, the bright, heart-shaped region that has become iconic in images of Pluto. Previously believed to be a static field of nitrogen ice, it is now thought to conceal a colossal underground ocean. This ocean, likely sustained by geothermal heat emanating from Pluto's rocky core, may remain in a liquid state beneath thick layers of ice. The implications are enormous. Protected from space's harsh environment, this ocean could host microbial life. If so, Pluto would join a growing list of icy bodies like Europa and Enceladus that might harbor life in their hidden seas. Adding to the intrigue is Pluto's varied and unexpectedly active surface. Towering ice mountains rival the height of Earth's tallest peaks, while smooth plains suggest recent resurfacing events. These geological phenomena hint at internal forces still shaping Pluto today. Convection beneath the surface causes nitrogen ice to slowly move and shift, revealing a process akin to molten wax in a lava lamp. Such activity was never anticipated for a body so far from the Sun, challenging old assumptions about where dynamic processes can occur. Pluto's interaction with its largest moon, Charon, further intensifies the mystery. The two bodies are so close in size that they orbit a shared center of gravity located in space between them. This gravitational tug-of-war generates internal heating, which may help maintain Pluto's subsurface ocean. Charon also displays features suggesting geological and chemical activity, including deep canyons and reddish stains on its surface. These reddish hues are believed to result from Tholins, complex organic molecules formed when ultraviolet light reacts with methane. Tholins, found on both Pluto and Charon, are particularly significant. Not only do they color the landscape, but they also represent the building blocks of life. Scientists speculate that these molecules could interact with subsurface water to spark prebiotic chemistry, a precursor to living systems. This opens the possibility that the elements needed for life might exist and interact far beyond the traditional habitable zone. Another surprising aspect of Pluto revealed by JWST is its atmosphere. Though extremely thin, it is surprisingly complex. Composed primarily of nitrogen with traces of methane and carbon dioxide, Pluto's atmosphere forms a hazy envelope that undergoes dramatic changes as the planet moves through its elongated orbit. When Pluto approaches the Sun, its surface ices sublimate, creating a temporary atmosphere. As it drifts away, the atmosphere freezes and falls back to the surface. This cycle of sublimation and deposition is unique and provides insights into how planetary atmospheres behave under extreme conditions. JWST's infrared imaging capabilities have been crucial in uncovering these features. They allow scientists to peer through Pluto's icy shell and detect heat signatures, chemical compositions, and surface changes invisible to previous missions. The data has identified organic materials, strange thermal patterns, and subtle magnetic interactions, painting a far more complex picture than ever imagined. The notion that Pluto may host a subsurface ocean and life-supporting chemistry is no longer pure speculation. It represents a plausible scenario supported by growing evidence. Earth-based comparisons, such as the life found near hydrothermal vents in our own oceans, suggest that life could exist in similar environments on Pluto. If confirmed, even microbial life would radically transform our understanding of where Pluto. From forgotten ice world to frontier of discovery for decades, Pluto hovered at the edge of public awareness, a dim, icy speck on the outer rim of the solar system. Once hailed as the ninth planet, its 2006 reclassification to dwarf planet felt like a demotion. To many, Pluto faded into obscurity, a forgotten world lost in the Kuiper belt. But now, Pluto is back, scientifically, spectacularly, and with cosmic vengeance. Thanks to groundbreaking observations from the James Webb Space Telescope, JWST, and data from NASA's New Horizons mission, Pluto is emerging not as a static frozen ball, but as one of the most dynamic, active, and mysterious celestial bodies we know. A world transformed what was once considered a cold, lifeless object has revealed a surprising level of geological activity. JWST's powerful infrared instruments have detected complex organic molecules, hydrocarbons and tholins, on Pluto's surface. These reddish substances may be precursors to life's building blocks, formed by radiation interacting with methane and nitrogen ice. JWST's deep scans have also helped confirm seasonal atmospheric changes and subtle shifts in surface composition, indicating that Pluto's environment is far more volatile and responsive than previously thought. This tiny world has weather, it has seasons, and, most stunningly, it may even harbor a subsurface ocean beneath its frozen crust. The hidden ocean beneath Pluto's icy heart, Sputnik Planitia, a giant glacier of nitrogen and methane. Scientists now believe there may lie a global ocean of liquid water. This ocean, kept warm by residual heat and possibly antifreeze-like chemicals such as ammonia, might be tens of kilometers deep. If confirmed, Pluto would join a select group of ocean worlds in our solar system, alongside Europa, Enceladus, and Titan. And with this realization comes a profound question. Could life exist in such an environment? Life, as we know it, requires water, energy, and organic chemistry. Pluto now ticks all three boxes. Though it's cold and distant, it might not be sterile. Hydrothermal activity at the ocean's base, similar to vents on Earth's ocean floor, could provide the energy needed to support microbial life. The future of Pluto exploration. Humanity isn't done with Pluto. Far from it. In fact, discussions are already underway for future missions, far more ambitious than New Horizons' brief flyby. Imagine an orbiter, launched by nuclear electric propulsion, slowly spiraling into orbit around Pluto. Imagine it deploying landers or even submersibles designed to melt through the ice and explore that hidden ocean. These aren't just science fiction ideas, they're early concepts that engineers are actively sketching out today. Such missions would stretch the boundaries of current spaceflight technology. But the payoff would be historic. A direct window into an alien ocean world, over 5 billion kilometers from Earth. Magnetism, atmospheres, and the solar wind. Pluto's interaction with the solar wind continues to puzzle researchers. Despite lacking a significant magnetic field, it still manages to retain a thin but dynamic atmosphere composed mainly of nitrogen, with traces of methane and carbon monoxide. JWST observations have revealed how Pluto's atmosphere expands and contracts with its elongated orbit, sometimes collapsing nearly entirely when farthest from the Sun. These interactions, and the way Pluto's atmosphere interacts with charged particles from the Sun, offer valuable insights into space weather, atmospheric retention, and the evolution of small planetary bodies. Even without a strong magnetic field, Pluto dances with the solar wind in unexpected ways. Studying this phenomenon can help scientists better understand exoplanets orbiting far from their stars. A cosmic mirror. Pluto is more than just a dwarf planet. It's a mirror reflecting our expanding understanding of the cosmos. It challenges our old assumptions about where life can exist and what defines a planet. It forces us to consider the importance of small, icy worlds in the grand scheme of planetary science. And it demonstrates how even the most overlooked places can become focal points of wonder and discovery. Humanity's growing curiosity. Why do we keep looking outward, toward cold, distant places like Pluto? Because every time we do, we discover that the universe is stranger, more beautiful, and more alive than we ever imagined. With every mission, every observation, we move one step closer to answering the most profound question of all. Are we alone? Pluto, once forgotten, now beckons us toward that answer. Its story is one of transformation, mystery, and